Okay, Wildcats. Today we're going to get Thursday, April 4th, solve exponential and logarithmic equations part 2. And that's going to be on page 69. If you would, update your table of contents. All right, now your table of contents is updated. Let's take a look at our examples. Now, before we get started, a couple things. You'll notice that I added lines to the work. I also moved example 2 up to the top. Now, if you have whiteout, you can white out the problem, okay? And also the date there, or you can just get some paper and just kind of work the problem and then tape it on. The next thing you notice, there's already kind of some work here, and that's because I've already actually started making this video, but then I didn't teach it as good as I could have, so I stopped the video and I'm going to restart it. And that's something I'm kind of want you to see is that when I make a video, I make sure it's a good video before I present it to you. That's one of the cool things about making video lessons is you can keep making a video and keep trying until you make the best video for your student. Okay, so that's what I'm going to do here for you. The best video lesson on solving exponential and log equations, part 2. All right, now with that, now you'll notice that here the bases are the same. Okay, so we can set the exponents equal to each other. So that's x squared equal to 16. Now, the next part is you take the square root of both sides. Now remember, the square root is plus or minus. Now the square root of x squared is x. The square root of 16 is both positive 4 and negative 4. Okay, now we're going to check. Let's check x equals 4. So now that's 3 to the 4 squared is equal to 3 to the 16. Well, 4 squared is 16, so 3 to the 16th equals 3 to the 16th, so this checks. Okay, so now let's check x equals negative 4. So then that's 3. Whenever you square a negative number, it needs to be in parentheses. So negative 4 squared is 16, 3 to the 16th equals 3 to the 16th, so these both check. All right, let's take a look at example 2. All right, so log base 4 of x minus 1 plus log base 4 of 3x minus 1 equals 2. So here, we're adding when you're doing log, so you know this is multiplication. So we have log base 4 of x minus 1 times 3x minus 1 equal to 2. Now, I think on the page, this is a 3, but I changed it to a 4 here in the video because that was a mistake. So just, if you would, that's why that 4 is there, so that these 4s have to be the same in order for this problem to work, okay? All right, now we're going to do 4 raised to this and 4 raised to the second power. And the reason we're going to do that to both sides, if you want to quadri, what you do one side, you do the other. But for the next part is this way, this 4 to log base 4 becomes 1, so you're left with this, x minus 1, parentheses 3x minus 1. And then 4 to the second power is 16. Now we're going to FOIL. X times 3x is 3x squared. X times negative 1 is negative 1x. Negative 1 times 3 is negative 3x. Negative 1 times negative 1 is positive 1 equal to 16. All right. Now, we're going to combine terms here, subtract 16. So 3x squared minus 4x minus 15 equal to 0. Now, we need to find all the combinations that combine to be negative 15, or multiply to be negative 15, combine to be negative 4. So let's take a look. 1 times negative 15 equals negative 15. 1 minus 15 is negative 14. That doesn't work. 3 times negative 5 is negative 15. 3 minus 5 is negative 2. That doesn't work. 5 times negative 3 is negative 15. 5 minus 3 is 2. None of the combinations work. So this is not factorable. So we're now going to use the quadratic formula. So x equals negative 4 is a positive 4 plus or minus the square root of negative 4 squared minus 4 times 3 times negative 15 divided by 2 times 3. Well, that's x equals 4 plus or minus the square root of 196 divided by 6. Well, the square root of 196 is 14, so x equals 4 plus or minus 14 divided by 6. So we can go ahead and plug that into the calculator to find the two numbers. So control divide. 4 plus 14 divided by 6 is 3. Highlight, enter. So 3 and negative 5/3. So x equals 3 and x equals negative 5 divided by 3. All right, so now we need to check So let's start by checking x equals 3. Okay, and you can honestly just plug this into the calculator. So control log base 4 of 3 minus 1 plus log base 4 of 3 times 3 minus 1. You can see that 2 equals 2. So this checks. Okay, now let's check x equals negative 5 divided by 3. Okay, so I can highlight, enter, and instead of the 3, I'm going to change that to negative 5 divided by 3. And instead of the 3 here, I'm going to change that to negative 5 divided by 3. You can see here that it's an error. So we can say that this is an extraneous solution. So an error does not equal 2. So this does not check. So you have x equals 3 and x equals negative 5/3 is an extraneous solution. All right, so go ahead and finish up example 1 and 2. All right, let's take a look at example 3. All right, so here you have log base 9 equals 5. So what I'm going to do is I'm going to make this 9 raised to the log base 9 of x squared. But remember, what you do one side, you do the other. And the reason I'm going to do this is because this becomes 1, and then you're left with x squared equals 9 to the 5th power. Okay. So then you're going to take the square root of both sides. Remember, square roots plus or minus. So you have x equals, let's go ahead and do that. Control square root of 9 to the 5th power is 243. So x equals a positive 243 and x equals a negative 243. All right, at this point we're going to check. Let's check x equals 243 first. Okay. So I actually need to move to this side. So then that's control log base 9 of 243 squared is 5. So you can say that 5 equals 5. So this checks. Now let's check x equals negative 243. So real simple. Change this to, now this one you have to be careful though. Parentheses, it has to be in parentheses squared. You see 5 equals 5, so they both check. All right, go ahead and finish up example 3. All right, now just like in example 3, we did a 9 here, we're going to do the same thing with the 4. Okay, this becomes 1 here, so then you're left with x minus 1 equals 4 to the third power is 64. So you add 1 to both sides, x equals 65. Okay, so now let's check. So we have log base 4 of 65 minus 1. You don't need a calculator to check this one. You can do this without a calculator. 65 minus 1 is 4, so you have log base 4 of 64 equals 3. Well, you ask yourself, 4 to what power gives you 64? The answer to that is 3, so 3 equals 3, so this checks. All right, go ahead and finish up those examples. All right, let's take a look at example 5. So here we need the same base. Well, you ask yourself, well, what base could we use? Well, we can use 2. So 2 to the second power times 3x minus 1 is equivalent to 2 to the third power plus 1. And let's go ahead and extend this line so we have space to check. Oh, that's a terrible line. Let's try to straighten that line out. All right, so now bases are the same, exponential equivalent. So let's go ahead and distribute as we set them equal to each other. So that's 6x minus 2 equal to 3x plus 1. Go ahead and subtract 3x from both sides. Add 2 to both sides. You get 3x equal to 3. And actually I made a mistake. Hold on. This is a common mistake a lot of students make. I multiplied 3 times x plus 1, but I forgot to multiply 1. 3 times x is 3x. 3 times 1 is 3. So 3 plus 2 is 5. Divide by 3, x equals 5 divided by 3. All right, so now let's check. Okay, so that's 4 to the 3 times 5/3 minus 1 equal to 8 to the 5/3 plus 1. So then that's 4 to the 3 times 5 divided by 3 minus 1 is 4 equal to 8. 5/3, 5 divided by 3 plus 1 is 8/3. Seems weird, but let's check. 4 to the 4th power is 256. And 8 to the 8 divided by 3. Wouldn't you know it? It looks weird, but it checks. 256. All right, let's take a look at example 6. All right. Now here, we're actually going to do something a little different. We're going to actually do the log base 3 of both sides. So log base 3 of 3 to the 2x minus 1 equals log base 3 of 20. And the reason we do that is because now log base 3 of 3 is 1. You're left with 2x minus 1 equal to the log base 3 of 20. We're going to add 1 to both sides. So 2x equals log base 3 of 20 plus 1. And then divide by 2. X equals log base 3 of 20 plus 1 divided by 2. And let's go ahead and find the decimal of that. X equals, so we're going to put that in the calculator. So control log base 3 of 20 plus 1 is, oh, wait a sec, almost forgot. We've got to divide by 2. Control log base 3 of 20 plus 1 divided by 2. And let's go ahead and round 1 decimal place, so that's 1.9. Now remember, when you check, you can't use 1.9 to check. You have to use the answer or solution in its entirety. Okay, so let's go ahead and do that. Let's check. Now, I'm saying checking x equals 1.9, but I'm actually going to plug the entirety into check. So to do that, we have 3 raised to the 2 parentheses control divide log base 3 of 20 plus 1 divided by 2 minus 1 is 20. So 20 equals 20, so it checks. All right. Let's take a look at example 7. All right. So here we're going to there. And the reason we're doing it that way is because this becomes 1, and then you're left with 5x plus 3 equals 7 to the 3rd power is 343. Let me adjust the lighting a little bit. Sorry, the sun is rising as I'm making this video, so I apologize for the lighting discrepancies. All right, subtract 3 from both sides, so you get 5x equals 340 divided by 5. X equals 68. And then let's check. Okay, so you have log base 7 of 5 times 68 plus 3 equals 3. So then that's log base 7 of 5 times 68 plus 3 is 343 equals 3. Wouldn't you know it? 7 to the third power is 343, so 3 equals 3. So that checks. Example 8. All right. You have log base 6 of both sides, so we're going to do 6 here. And the reason why is this becomes 1, this becomes 1. You're left with 2x squared plus 3 equals 5x. Okay. Now we're going to subtract 5x from both sides, so you get 2x minus 5x plus 3 equals 0. Now, whenever you have a number other than 1 in front, you want to factor probably using the reverse box method. Now, you know that you have, that's 2x squared, and 3. So you know that 2x and 1x make 2x squared. Now, the question you ask yourself is, what makes positive 3? Well, a negative 1 and a negative 3. Okay? But you want the negative 5 to be the bigger number, so we're going to put the negative 3 here and the negative 1 here. 2x times negative 3 is negative 6x. Negative 1 times 1 is negative 1x. And I'm saying that that doesn't work. So we have to try the other combination. So now let's put the negative 1 here, negative 3 here. So then that's negative 2x, that's negative 3x, becomes negative 5x. This works. So your factors are 2x minus 3, 1x minus 1. Equal to 0. So you have 2x minus 3 equal to 0. X minus 1 equal to 0. Add 3 to both sides, divide by 2. X equals 3 divided by 2. Add 1 to both sides. X equals 1. So now we need to check. X equals 3 divided by 2. Let's do that first. And we can use our calculator to do that. Okay. So control log base 6 of 2 parentheses 3 divided by 2 squared plus 3 is 1 point, let's just say 1.1 equal to control log base 6 of 5 times 3 divided by 2 is 1.1. So this checks. Okay. Now let's check x equals 1. Okay. Now that one you can actually probably just plug the numbers in. Log base 6 of 2 times 1 squared plus 3 equals log base 6 of, well, 5 times 1. 2 times 1 squared is 2 plus 3 is 5. So you have log base 6 of 5 equals log base 6 of 5. So that checks. So these are your solutions. Okay. Let's take a look at example number 9. Okay. Now here we have 5 to the x equals 50. So we can actually take the log of base 5 to both sides. So log base 5 of 5 to the x equals log base 5 of 50. So then this becomes just x equals log base 5 of 50, which we can put that in our calculator, is 2.4. So let's check. And that's a terrible line. Let's try to fix that line. Okay, so let's check x equals 2.4. So remember, when you approximate, you can't plug that number in. You have to plug in the initial problem. So let's do that. So 5 up key, control log base 5 of 50. You see 50 equals 50. So this checks. Okay. So now, last example, probably the longest video I've made ever. So here, remember, if the base isn't given, we say it's 10. We subtract, we divide. So we have log base 10 of 3x plus 1 divided by 4 equals 2. We're going to raise both sides by 10. This comes to 1. You're left with 3x plus 1 divided by 4 equals 10 squared is 100. Divided by 1. We're going to cross multiply and solve for x. So 3x plus 1 times 1 is 3x plus 1. 4 times 100 is 400. Subtract 1 from both sides, you get 3x equals 399. Divide by 3. X equals 133. Okay, and let's check. X equals 133. Now, this one's probably just one we want to probably plug into the calculator since it's so long. So 3 times 133 plus 1 minus log base 10 of 4. We see 2 equals 2, so that checks. All right, if you would, go ahead and finish up your examples and have a wonderful Wildcat day.